for example. Not C, so change that to Kelvin. I misclicked it. Okay, which is 185C. And how do I find the vapor pressure at any? I give a vapor fraction. Doesn't matter what. I can put 0. I can put 1. It will be the same answer. Let's put 0.5. Same answer. Okay, so if you specify a vapor fraction, you specify that you have vapor-liquid equilibrium. Okay, so that completely fixes it, and that's the vapor pressure at 275. Now we're going to do a calculation. I need to calculate, since I'm going to create a plot of ln, I need to be calculating ln, right? And I need to calculate 1 over t. So if I'm going to do calculations, I need to bring the spreadsheet, double click on the spreadsheet. I think it's enough what we have, so I don't think we need to add any columns. So I need to import two things: temperature and vapor pressure. So temperature, you right click, import variable, go to, I didn't name it, so it's default name 1, and I want the temperature. Click OK. And I want the vapor pressure. Right click, import variable. What's vapor pressure? It's the pressure. I may calculate the vapor pressure by putting the vapor fraction, giving the vapor fraction of the temperature. So pressure. Okay, should I make an error on purpose? Let's make an error on purpose. So I need 1 over t. So equals 1 divided by cell A2. Good?
No.
Okay, Brian, I was wrong.
Would that always cause it to be divided by A2 even if you expanded it? Or like if you added
It's in Celsius.
Celsius.
Exactly. This relationship should always be in Kelvin. This relationship that the Antoine and the Clausius equation and the Clausius-Clapeyron equations, temperature must be in Kelvin or Rankine. Must be an absolute temperature. So that's incorrect. So what I want to do is 1 over parenthesis A plus 273 Kelvin. All right. And I need also the natural log. So this would be ln P vapor. Remember how we get ln in unison? At equals at ln of V2. Actually, there's one other calculation I would like to make, and let's make one more calculation. Let's calculate delta H, vapor minus liquid. Okay? So let's import delta H over R. Let's calculate dH over R. So, okay, we need H molar vapor, H molar liquid. So, double click, import variable, string 1. I need to do something else for that. I don't think I can get off the label face. Let's see. Yeah, I can. Okay, sorry. I need to create two other strings for that. For this, what I want here. I need to create a string in which I have those conditions, but I have only vapor, and those conditions, and I have only liquid. So let's make a copy of string 1. You can say right click, cut paste objects, clone, and let's name this vapor. And what I will do, I will change the mole fraction, vapor mole fraction to 1. That affects the enthalpy, okay? The pressure doesn't change as I change that, but of course the enthalpy changes. So when I have vapor, you see the molar enthalpy is minus 241,000. If I change it to liquid, minus 286. Okay? So because I want to calculate the delta H to show you something, let's make one string for vapor, and let's make a similar copy. Again. Now, the command clone is only good if you have defined everything, if nothing is calculated. Otherwise, you have to use define from a string. So let's name that liquid. And change that to 0. So now I have at 185 temperature, at 275 Kelvin, what is the H of the vapor and liquid phase. Go to the spreadsheet, so import from the vapor stream, vapor, import molar enthalpy. Click OK. Import from the liquid stream, molar enthalpy. And d delta H over R is simply equals the vapor, so A5 minus the liquid, V5 divided by R, 8.314. So that's that delta H over R. Shall I go too fast? Yeah. Sorry. Anyone needs me to repeat something? Jessica, doing okay? No? No. Where do you want me to repeat? Where did you lose me? You good? Brad, you have a computer? Jamal, you have a computer? Jamal, are you okay? Say it louder? Yeah, the stream vapor, it's everything identical except the vapor fraction is 1. Stream liquid, the vapor fraction is 0. So to calculate the delta H of the phase change, the field of vaporization, I need to subtract H vapor minus H liquid. That's the delta H of the phase change. Divide that by R. Why do I do that? Because that's the big coefficient, right? So I want us to do that and see how close we come to the essentially closest Clapeyron equation. Okay. So now let's go back to the spreadsheet. Now we're done with the spreadsheet. We want to plot cell 1 over T on the x-axis, which is cell C2, and Ln vapor pressure on the y-axis, cell D2. So C2 and D2 are the two cells at B1. So how am I going to generate a plot? I'm going to generate a case study. So go to Tools, Data Book, and Variables, Insert, and I want from the spreadsheet, and I want cells C2 and D2. So C2, add, and D2. I won't actually be able to do the plot directly, though I'll have to go to Excel to do it at the end. I also need what I'm going to be changing. What am I going to be changing? The temperature of stream 1 from 275 to 475 Kelvin. So temperature is stream 1 temperature. Important thing, in a case study you can only change something that you have defined. I have not defined the 1 over T. I have defined the T. So the the variable that changes has to be temperature, cannot be unfortunately 1 over T. Okay. So we should have 3 variables here. Close. We should be saying spreadsheet cell C2. That was the 1 over T calculated value. Spreadsheet cell D2, Ln vapor pressure, and spreadsheet the temperature. So in my case study, I will vary the temperature from 275 Kelvin to 475 Kelvin, and I will get the results of what 1 over T is and what Ln vapor pressure is. I can only get plots with the x-axis being the variable I changed T. To generate the Ln vapor versus 1 over T, I will export things to Excel and plot them in Excel. Okay, clear what I'm doing? So, let's do the case study. So after variables, go to case studies. Before you can specify it, you need to add the case study. So click add. You can take the default name. In this case, it hasn't messed up, so it allows you to have independent only. Sometimes if this messes up, it shows you as allowable something that you didn't define, but if you try to do it, it won't never work. But here, incorrectly, doesn't allow C2 or D2 to be changed. It allows only independent variable to be the temperature. So select temperature in the independent variable, select the other two to be the dependent variables. Remember what we do next? View. Lower bound 275 Kelvin. Higher bound 475 Kelvin. And we can have step size 5 degrees should be a good step size. 5 Kelvin or C is the same thing. And click start. And if we look at the results, the plot, obviously, C2 is 1 over T, 1 over T base inverse, and this is versus 1 over versus T, and versus T is not a straight line. How can I get the data I can use to plot in Excel? If you click table, which seems promising thing, that's not going to be very helpful. Transpose table is what we want. Click transpose table. There you have them nicely in tabular format. And what we need is 1 over T versus LNPV. So we need to export to Excel column C2 and D2. So highlight all those, go all the way down, even though it didn't show it. Control copy, open Excel. Yes, no. So let's do it from the second so I can put some title. Control V. So here are my data. And so this is 1 over T, and because I added 2.73 is in Kelvin, and this is ln P vapor. So let's plot them. It's okay if I select too much, it doesn't work. So go now to insert. Am I going too fast? Slow me down if I go too fast. Yes, I'm going too fast. So everybody exported to Excel, okay? Is anybody who needs help with exportation? Okay. In Unisim you're talking about? In Unisim, when you do transpose table, you should be seeing those numbers. So to check if it's right, this is the beginning numbers, 1.85, 3.68, and the next value is 6.85. Are you all okay here? Just you okay?
No, my Unisim crashed a long time ago.
Rico okay? Dylan okay? Chris okay? No computer. Guys, remember we have a computer exam coming up. Make sure your computers are in good working order for that computer exam. Anybody needs more time at this stage? Okay. So select the last two columns from the very top. Scroll up to the very top. Assuming you can do better than I do. Okay. From the very top. Okay. The 3.63 D2 all the way down. Even though you don't see it, go all the way down. Control copy, and then you go to Excel. Start on the second cell, Control V. I'm sure I did everything right here. You should have how many entries? You should be ending at 42. 42 is the last one. Okay. All right. And you all know how to plot in Excel, or is there anyone who doesn't know how to plot in Excel? Okay, nobody wants to admit it. It's easier to plot when you have your x-axis is the leftmost column, and the others. You can do it anyway, but so the easiest way to start a plot is select, and it's good to include the titles. Select the two columns, and then you go to insert. Go here, it says charts, and we want always scatter chart, not line chart. Remember the T against the land vapor pressure? It certainly had curvature. Look at this. It's pretty much a straight line, right? If you look at that plot, you can see